Well, thank you ever so much for having me today. So I'm James Thomas. I'm sort of building a 5G at sea business, and I think today I was going to talk through some of the things we've learned so far about the environmental benefits of 5G, and maybe a little bit about what we've been doing as well. Um, so if I start off with what one of the main things we've realised as we've started to go down this journey is there's so many different use cases for 5G around the coastline, and what I found was really interesting about that is they've all got environmental benefits to them. Um, we've seen the use of autonomous platforms as one of the really interesting use cases for 5G because it fundamentally means that we're looking at how do we get that platform from A to B as efficiently as possible and reduce that carbon footprint. There's been some work in aquaculture. I think one of the projects I'll talk about in a little bit more detail is all looking at sort of seaweed growth and things like that, and doing some AI on the seaweed growth to understand better how we can be efficient with our aquacultural farming. There's bits and pieces of smart port infrastructure that I can see coming, and again, that will enable sort of things like use cases such as sort of VR to happen. So instead of sending a pilot out, you'd send out your VR headset and manage the ship in that way. And the one that we're deploying in rural Dorset is one of our, we've called them SCMS systems, but they're basically a sea state monitoring system where we're looking at sort of piecing together data at sea. So what we can realize is with all these use cases comes the need for data, and the data I think is going to help us with things like habitat mapping, things like seagrasses, etc., and sort of so we can understand the impact of the climate change in real time. So and potentially even quantifying the natural benefits of that. So as I move on, if that's okay, we've got the first thing we've been doing is we've been looking at this as a buoy, and this is one of the things we're sending to sea, and we realised that they're made out initially out of plastic, and we don't think that's a good idea to be doing that longer term. So one of the things we've been doing is we've been looking at how do we design a platform that floats. And if I start you off with where we're going as a project, we're putting a buoy at sea with a 5G router in it. And we thought, well, that's about the toughest use case you can prove out the hardware with. Living in one of those things for a year kind of would give you sort of a bit of a challenge in terms of how do you get connectivity, maintain connectivity, and we're doing it over a completely new network system. So we're on the N28 and N78, so that's 5G standalone. So we've got the routers working, which is great. A lot of help from the satellite application catapult, and I think we will probably the UK's first, if not one of the world's first routers that's working in the field, which is quite cool actually to be able to say something like that. And then we've not only done that, we've then put that in a floating platform made of flax fiber. And that gives us quite a nice use case because we've actually taken traditionally something that we made out of plastic and turning it into something that's made out of recyclable, renewable materials. But that's not to say it hasn't had some of the challenges associated with being made out of flax fiber with it. But it's interesting because it gives us this use case for 5G, which is, I expect there's be a lot of comments around well, you don't need 5G to do what you're doing, but actually 5G gives us something a bit more longer term, because we want to have buoys talking to other buoys at sea, so we can actually extend that range of the 5G coverage a lot further offshore. So one of the things we're looking at is sort of, I think it's called relay cell mode, trying to get each individual mark talking to the next one down the coast. So we've got 3 going out in rural Dorset, and we're trying to get them talking to each other as well as talking back to the base station. So that's going to be interesting to see how we manage the messages between that. And that's one of the things I think that comes out with the use of 5G. Now, the data rate on these is actually quite interesting as well. One of the other application cases that we're putting on this, and we haven't announced this yet, but it's all around putting some situational awareness on these. So cameras that can look at monitoring, and the AI on the camera that we're embedding should hopefully be able to look at number of people down the cliff faces, number of sailors, surfers, whatever we want the AI to detect. But that will enable some other interesting use cases coming along. And also what we can then see is when we've stacked all these use cases together, not only have we embraced sort of all the innovation within the design and development, but we've actually made it into sort of a sustainable project by the stacking of applications on the floating network, ranging from obviously the more traditional things that we're looking at, such as the sea monitoring, through to the AI. So I think it's probably worth going through a little bit of what we've been doing on rural Dorset. So rural Dorset, beautiful place. Rural Dorset's one of those really great projects to have been involved with, and I'm really grateful to the team down there that were running it. They've brought us in on quite a few areas now, which has been great. We've done modems for signs, for footfall counters. We've got some aquaculture work going on, and we've also got some sea safety work, as I mentioned, going on. So I think we've got about 9 or 10 different products going in down there, which is good to see because it's going to give us a range of testbed and trials data. And I think that the testbed and trials data is really useful. It's going to give us a lot more learning. Now we've got deployments going to sea over the next month. We've got deployments going on land as we speak, and they're going out over the next period of time. And what the hope is from those application cases, we're going to start to learn a lot more about the monitoring and how we can achieve things. The value proposition that we're putting together for 5G for ourselves, again, as I mentioned before, is trying to extend that coverage from the land to the sea by getting each buoy to talk to the next buoy and extend offshore, and then stacking applications on that, all for benefit. What's really nice about that is I was talking to a postdoc researcher this morning, all around the amount of data, and if we start to look about changing our maritime architecture, which is traditionally just a dumb buoy that sits there, which is just a floating plastic box, into something that's flax fiber, so it's not going to damage the world necessarily, and it's also then able to communicate. We've got such big scale data that we can start to collect along our coastlines, so we can understand what level of carbon sequestration we've got in the seas, noting that the ocean is one of the massive carbon sinks the planet has, and we need to be very careful about that. So yeah, we've got an aquaculture project, as I mentioned. Now, aquaculture is a really big high potential opportunity for the region, and I think what that means is it's the growing of sort of seaweed, shellfish within the harbour down there. As a project that we're working on there, it's quite nice because it's a really green use case, and it's a really inclusive little team. So we're putting 2 cameras underwater looking at seaweed growth, and that's going to give us sort of a large bank of data. Now we do have some challenges around the buoy platforms and power usage, and that's our big challenge. So we're going to have to manage carefully how we do that over the winter. But in the summer, we should be able to be streaming live video non-stop from the cameras, which is going to be a huge benefit to understanding that growth and movement of that seaweed, and see how quickly it matures and in what climate, along with the other sensors we've got going out there. So we've got a range of wind, temperature, etc., that sort of sensors. Now, on the other coastline, it's less environmentally focused. It's more about personal safety. So we're looking at wave frequencies, heights, periods, as well as some cameras around people who's going to be on the coastline, and realistically, that's all around on the obviously it's a UNESCO World Heritage Site, looking at what actually impact the sea has on the safety of people going to the beach that day. So I've tried to wrap that up fairly quickly. So sorry if I've made a mistake with your timeline, Pascal, but I think that the ending message from us is that we think that the data is going to enable the positive sustainable change, because we're going to find that having more data gives us an ability to understand more about what's going on out there. And by we're going to talk about how we mesh our buoys and take that comms out offshore. That gives us not only a benefit in terms of coverage, it gives us a benefit in terms of data rate, and it gives us a benefit in terms of the large scale amount of data we're going to have. We're obviously quite focused on maritime applications, but I think a lot of the hardware we've developed could be used in other applications. It is just rugged 5G that works on a number of different bands. We're quite focused on sort of things like beamforming antennas as well. So things like that are quite important for us, but in a different sense from in the smart city, because what we want to do is we want to enable that data to continue flowing down that coastline. But yeah, hopefully that's been interesting.